Hey, this is Don from Padlock Technologies again with another video. This time I am going to be talking about clustering. Got a question about that. I did do a couple videos about clustering, but I'm going to go into a little bit more detail of clustering. Now, this is on an ASA or an FTD. Now, I can also do a lab. I already showed you in the lab that I have the ASA cluster. Unfortunately, the virtual FTDs can't do that, but it's the same concept. It's just different technique on how to do it on each platform. So clustering is basically, let's go to this whiteboard here. Clustering is basically a technique where you're going to take up to 8 firewalls and make it look like one logical firewall. Most of the times I see this design though. I'll see C1 cluster 1, cluster 2, link. This could be a core, a collapse core, right? And then another switch, ISP. You can have multiple ISPs, but we'll just do that. That's most of the time we're going to see it. Now, what you can do though is this design. If now there's a capex hit to this, so you just got to be careful. So you can have C1, C2, 3, 4. We'll just do 5 for now. C5. Then you have, I'm going to draw C switch for the cluster switch. So all these lines are going to be port channels here. Now they're not going to be the same port channel. Let me tell you that right now. It's not going to be the same port channel because you do not want to do that. Core. INET switch. And then ISP. Okay. So those are the two designs that you're going to see. All right. Because you can do up to 8. Now, the reason why you have this switch here is because these green lines are going to what's called a CCL, cluster control link. This line here, CCL, cluster control link, right? That link is hyper important because that ultimately is going to be how you're going to form the cluster, right? So in either design here though, this box looks like one box. All 5 of these cluster nodes look like one node, all right? So there's 2 ways you can do this. There is 2 interface modes, by the way. So there's interface mode for the cluster mode or cluster interface modes. So there's interface mode, which rarely anybody uses. And then there's span mode. So I'm going to talk about span mode because rarely does anybody use interface mode. So with span mode, what you're going to do is you're going to form a port channel. So say this is port channel 1, this is port channel 2. Same thing here. Port channel 1, port channel 2. And just like the name implies, this port channel is going to span every link, every node here. So it's going to go across here, right? So to the upstream and the downstream switch, it's going to look like one port channel, right? So here at the switch layer, it's one port channel, right? And this is why it's going to span the cluster and why when traffic goes upstream, it can hit any one of these ASAs or FTDs. Any one of these can answer, right? On the cluster control link, you cannot have one big port channel because each node is going to send its own system ID, so our LACP system ID. So you got to be careful about that, right? Because if you do one big port channel, the port channels won't come up and then you'll have a problem forming the cluster for that reason. So each one of these links that go into each respective node is going to have to be port channel 1, port channel 2, port channel 3, port channel 4, and port channel 5, right? And they're going to have their own address here. So the cluster node address, let's say you had a slash, that's 5 here. Let's give it a 248, so you have 6 usable IPs. So then you can assign each one of these a IP address in the same subnet. So the cluster address for this one would be .1, .2, 3, 4, and 5. And let's say this is slash, I'll just say 248 for right now. Don't get me on the CIDR notation. I always blank out on CIDR notations, right? Now, the other thing from a management standpoint is you're going to have an IP pool to, so a local IP pool to, I'll just say it's local, IP pool local, to assign the management addresses. Management, all right? And then that management address, when you configure your management interface on this master node, let's say C1 was the master, then you're going to say pool, whatever the pool address is, and then it'll automatically assign the next address in the next one up, right? It'll assign the next one up in the cluster. So, and it's the same thing on this 2 node cluster over here. So if you assign it on the master, it assigns it to the slave over here. And that's the concept. There's master, slave, right? When it comes to joining a cluster. Now, you're probably going to ask, well, what about asynchronous, traffic flow? Well, it handles it pretty simple. So in clustering, there are 3 roles. There is the owner, there is the forwarder, and then there's the director. All right. So the owner is the person that owns the TCP flow, right? The initial handshake there. The forwarder will be the person that if it comes to them and they don't own the actual session, they need to forward it to the owner. The director is the person that knows about all the flows, right? So when the forwarder says, hey, I don't own this flow, it'll go to the director. The director say, okay, this person owns the flow or this node owns the flow. And then the forwarder will forward that flow back to the owner to complete the session, right? So how does that look like from a flow standpoint? There's a lot of mess on the whiteboard here. So let's see, what color can I use? I'll use red. So say this is the owner of the original. Say this is the director and this is the forwarder. So I'll use green. So let's say it goes out this side here, goes out to the ISP. When it comes back, it hits this firewall. The firewall says, I don't own this session. So it goes to the director. So do a red line and says, who owns this? And waits for the reply. Once the reply comes back and says, hey, node 1 owns it, then it forwards that TCP connection or that session connection back to the owner, and the owner forwards it back down to you. So that's how it manages the asynchronous data flow. And it really depends on, you don't have to, there's no priority to make it the director. Now there is priority in the cluster for master and slave, but there's no priority to make it the director. And again, I would use this for internet-based firewalls only. I wouldn't use this for something that has VPNs on the top because the only thing that can do the VPN at that time is the master. So there's no point in this. This is really, when we talk about network design, I would really say, hey, do this on the internet layer and do active standby for RAVPN and site-to-site VPN traffic, right? Get another 2 nodes or 2 firewalls and then just do active standby for this. For this specific design for clustering, I'm not gonna say best practices, but I would say, hey, if you're gonna use this internet only, do clustering so then you can maximize all the nodes. That's really the benefit of clustering here. And I forgot to put a line there. That's the benefit of the clustering, right? Because in active standby, you're utilizing 1 box and 1 box only. It gets all the pressure, right? In clustering, this basically active forwarding. So if you had 8 nodes across the board, you're utilizing all 8. All right. So you got heavy traffic loads going out to the internet. Box 1 is not the only thing taking all the traffic. In an active standby situation, box 1 would take all the traffic, right? And then you can have CPU utilization problems, especially when you start adding on next generation stuff that's IPS and malware, you start adding that on. Now Snort is getting blitzed because it's all that traffic's going out of one box. Now make sure you size the box appropriately, barring that. But you want to make sure that everything is being utilized, right? Maximum utilization out of the hardware you have. And clustering is a way to do that. Now, in the FTD platform or the ASA platform, you can do it per node. So you have to buy the hardware. But like I said in my other video about the differences between multi-context and multi-instance, you can do intra-chassis or inter-chassis clustering based on the 40,000 series and the 9,000 series, right? So you can have multiple instances in here, and instead of running active standby, you would run clustering intra chassis. Again, the downfall of that is if the entire chassis goes to crap, all the clustering is gone at that point, right? But if you do it with separate boxes, let's say box one goes down, well, it's transparent to the user because you're spreading your traffic amongst all the other nodes. So if box one goes down, obviously somebody else is going to get there's going to be an event where someone has to be a master because the original master went down, but traffic is still going to be flowing to the next. Now you have 7 more boxes to send traffic to. You can kind of figure out what's going on with the master, bring it back in, and you can join it to the cluster, and it will join as a slave. It will not become a master again, unless you manually change it to a master, right? That is the clear benefit of this. So hopefully that answers your question about, what is clustering? Why would you use clustering? What's the technical details, how traffic flows? Again, if you're looking to get something like this in your environment, it's going to be links in the description below. Hopefully this video was informative. This is Don from Padlock Technologies again. Thank you and have a nice day.